Oracle VM VirtualBox is a virtualization software package for x86 and 64 Armenian DRAMs per Intel 64-based computers from Oracle Corporation as part of its family of virtualization products. It was created by innotek GmbH, purchased in 2008 by Sun Microsystems, and now developed by Oracle. It is installed on an existing host operating system as an application. This host application allows additional guest operating systems, each known as a guest OS, to be loaded and run, each with its own virtual environment. Supported host operating systems include Linux, Mac OS X, Windows XP, Windows Vista, Windows 7, Windows 8, Solaris, and OpenSolaris. There are also ports to FreeBSD and Genode. Supported guest operating systems include versions and derivations of Windows, Linux, BSD, OS/2, Solaris, Haiku and others. Since release 3.2.0, VirtualBox also allows limited virtualization of Mac OS X guests on Apple hardware, though OS x86 can also be installed using VirtualBox. Since version 4.3, Windows guests on supported hardware can take advantage of the recently implemented WDDM driver included in the guest editions. This allows Windows Aero to be enabled along with Direct 3D support. History: VirtualBox was initially offered by innotek GmbH under a proprietary software license, making one version of the product available at no cost for personal or evaluation use, subject to the VirtualBox personal use and evaluation license. In January 2007, based on counsel by Lee So-ji, innotek GmbH released VirtualBox Open Source Edition as free and open source software, subject to the requirements of the GNU General Public License, version 2. innotek GmbH also contributed to the development of OS/2 and Linux support in virtualization and OS/2 ports of products from Contix which were later acquired by Microsoft. Specifically, innotek developed the A-Euro editions Eurocode in both Microsoft Virtual PC and Microsoft Virtual Server, which enables various host guest OS interactions like shared clipboards or dynamic viewport resizing. Sun Microsystems acquired innotek in February 2008. Oracle Corporation acquired Sun in January 2010 and rebranded the product as Oracle VM VirtualBox. Licensing: with version 4 of VirtualBox, released in December 2010, the core package is free software released under GNU General Public License version 2. This is the fully featured package, excluding some proprietary components not available under GPL v2. These components provide support for USB 2.0 devices, remote desktop protocol and pre-boot execution environment for Intel cards and are released as a separate VirtualBox Oracle VM VirtualBox extension pack under a proprietary personal use and evaluation license, which permits use of the software for personal use, educational use, or evaluation, free of charge. Oracle defines personal use as any situation in which one person installs the software, and only that individual, and their friends and family, use the software. Oracle does not care if that use is for commercial or non-commercial purposes. Oracle would consider it non-personal use, for example, if a network administrator installed many copies of the software on many different machines, on behalf of many different end users. That type of situation would require purchasing a special volume license. Prior to version 4, there were two different packages of the VirtualBox software. The full package was offered free under the PUEL, with licenses for other commercial deployment purchasable from Oracle. A second package called the VirtualBox Open Source Edition was released under GPL v2. This removed the same proprietary components not available under GPL v2. VirtualBox requires the use of the OpenWRTSOM compiler to build the BIOS since version 4.2. Although VirtualBox has experimental support for Mac OS X guests, the end-user license agreement of Mac OS X does not permit the operating system to run on non-Apple hardware, enforced within the operating system by calls to the Apple System Management Controller in all Apple machines, which verifies the authenticity of the hardware. Emulated environment. Users of VirtualBox can load multiple guest OSs under a single host operating system. Each guest can be started, paused and stopped independently within its own virtual machine. The user can independently configure each VM and run it under a choice of software-based virtualization or hardware-assisted virtualization if the underlying host hardware supports this. The host OS and guest OSs and applications can communicate with each other through a number of mechanisms including a common clipboard and a virtualized network facility. Guest VMs can also directly communicate with each other if configured to do so. Software-based virtualization. In the absence of hardware-assisted virtualization, VirtualBox adopts a standard software-based virtualization approach. This mode supports 32-bit guest OSs which run in Ring 0 and 3 of the Intel Ring architecture. The system reconfigures the guest OS code, which would normally run in Ring 0, to execute in Ring 1 on the host hardware. Because this code contains many privileged instructions which cannot run natively in Ring 1, VirtualBox employs a code scanning and analysis manager to scan the Ring 0 code recursively before its first execution to identify problematic instructions and then calls the patch manager to perform in situ patching. This replaces the instruction with a jump to a VM-safe equivalent compiled code fragment in hypervisor memory. The guest user mode code, running in Ring 3, generally runs directly on the host hardware in Ring 3. In both cases, VirtualBox uses CSAM and PATM to inspect and patch the offending instructions whenever a fault occurs. VirtualBox also contains a dynamic recompiler, based on QEMU to recompile any real mode or protected mode code entirely. Using these techniques, VirtualBox can achieve a performance comparable to that of VMware. Hardware-assisted virtualization. VirtualBox supports both Intel's VTX and AMD's AMD hardware virtualization. Making use of these facilities, VirtualBox can run each guest VM in its own separate address space. The guest OS Ring 0 code runs on the host at Ring 0 in VMX non-root mode rather than in Ring 1. VirtualBox supports some guests only on hosts with hardware-assisted virtualization. Device virtualization. The system emulates hard disks in one of three disk image formats, a VirtualBox-specific container format, called Virtual Disk Image, storing files on the host operating system, VMware Virtual Machine Disk format, Microsoft Virtual PC VHD format. A VirtualBox virtual machine can, therefore, use disks previously created in VMware or Microsoft Virtual PC, as well as its own native format. VirtualBox can also connect to ISTC targets and to raw partitions on the host, using either as virtual hard disks. VirtualBox emulates IDE, ISTC, SATA and SAS controllers to which hard drives can be attached. VirtualBox has supported open virtualization formats since version 2.2.0. Both ISO images and host-connected physical devices can be mounted as CD/DVD drives. For example, the DVD image of a Linux distribution can be downloaded and used directly by VirtualBox. By default, VirtualBox provides graphics support through a custom virtual graphics card that is VESA compatible. The guest editions for Windows, Linux, Solaris, OpenSolaris, or OS/2 guests include a special video driver that increases video performance and includes additional features, such as automatically adjusting the guest resolution when resizing the VM window or desktop composition via virtualized WDDM drivers. For an Ethernet network adapter, VirtualBox virtualizes these network interface cards: AMD PCNet PCI2, AMD PCNet Fast 3, Intel Pro/1000 mount desktop, Intel Pro/1000 mount server, Intel Pro/1000T server. The emulated network cards allow most guest OSs to run without the need to find and install drivers for networking hardware as they are shipped as part of the guest OS. A special para-virtualized network adapter is also available, which improves network performance by eliminating the need to match a specific hardware interface, but requires special driver support in the guest. By default, VirtualBox uses NAT through which Internet software for end users such as Firefox or SSH can operate. Bridge networking via a host network adapter or virtual networks between guests can also be configured. Up to 36 network adapters can be attached simultaneously, but only 4 are configurable through the graphical interface. For a sound card, VirtualBox virtualizes Intel HD Audio, Intel IC AC97 and Sound Blaster 16 devices. A USB 1.1 controller is emulated so that any USB devices attached to the host can be seen in the guest. The closed-source extension pack adds a USB 2.0 controller and, if VirtualBox acts as an RDP server, it can also use USB devices on the remote RDP client as if they were connected to the host, although only if the client supports this VirtualBox-specific extension. Feature set, 64-bit guests, snapshots, seamless mode, the ability to run virtualized applications side by side with your normal desktop applications, shared clipboard, shared folders, special drivers and utilities to facilitate switching between systems, command line interaction, public API to control VM configuration and execution, nested paging for AMD and Intel VT, limited support for 3D graphics acceleration 3.0 and Direct 3D 9.0C via Wine's Direct 3D to OpenGL translation, SMP support, since version 3.0, teleportation, 2D video output acceleration, since version 3.1, storage. Emulation features, NCQ support for SATA, SCSI and SAS raw disks and partitions, pass-through mode for solid-state drives, pass-through mode for CD/DVD disks, allows to play audio CDs, burn optical disks, play encrypted DVD disks, can disable host OS I/O cache, allows to limit I/O bandwidth, PATA, SATA, STC, SAS, ISTC, floppy disk controllers, storage support, raw hard disk access. Allows physical hard disk partitions on the host system to appear in the guest system. VMware Virtual Machine Disk Format support. Allows VirtualBox to exchange disk images with VMware. Microsoft VHD support, QEMU. CAD and QCOW disks, HDD format disks used by Parallels virtualization products, since version 3.2, Mac OS X Server Guest support. Experimental, memory ballooning, RAM deduplication for Windows guests on 64-bit hosts, CPU hot plugging for Linux and certain Windows guests, deleting snapshots while the VM is running, multi-monitor guest setups in the GUI, for Windows guests, LSI Logic SAS controller emulation, remote desktop protocol video acceleration, run and control guest applications from the host. For automated software deployments, since version 4.0, the PUELOSE separation was given up in favor of an open-source base product and a closed-source extension pack that can be installed on top of the base product. As part of this change, additional components of VirtualBox were made open source: Intel HD audio codec emulation, Intel ICH9 chipset emulation, a new VM storage scheme where all VM data is stored in one single folder to improve VM portability, several UI enhancements including a new look with VM preview and scale mode. On 32-bit hosts, VMs can each use more than 1.5 GB of RAM. In addition to OVF, the single-file OVA format is supported. CPU use and I/O bandwidth can be limited per VM, support for Apple DMG images. Multi-monitor guest setups for Linux Solaris guests, resizing of disk image formats from Oracle, VDI, and Microsoft, VHD, since version 4.1, Windows Aero support, virtual machine cloning, since version 4.2, virtual machine groups, allows you to manage a group of virtual machines as a single unit. Some VM settings can be altered during a VM execution, support up to 36 NICs in case of the ICH9 chipset, support for limiting network I/O bandwidth, can automatically run VMs on a host system startup, since version 4.3, VM video capturing support, host touch. Devices support USB virtualization of such devices, the extension pack. Some features require the installation of the closed-source VirtualBox extension pack, support for a virtual USB 2.0 controller, VirtualBox RDP, support for proprietary remote connection protocol developed by Microsoft and Citrix. PXE boot for Intel cards, see also. Comparison of platform virtual machines, hypervisor, LHC at home, distributed computing project for particle physics at the Large Hadron Collider that uses VirtualBox, platform virtualization, virtual disk image, references. External links, official website, sub-site at Oracle, VirtualBox downloads, all downloads index. For example, for guest editions,